So for the last example here, you're given the derivative. So you really have to pay attention to this, right? Right here. So it says, where is f of x increasing? Well, f of x, it's not f prime of x, it's where f of x is increasing. F of x is increasing where the first derivative is positive. So, and the endpoints there. So the first derivative is positive here and that part there. So that means it's going to be negative infinity to negative 3 union. I'm not asking for what open interval, so we want to make sure it's inclusive. 1, 5, like so. And the same for the decrease part. The decreasing would then be wherever the first derivative is negative. So that would be from, now I'm having trouble seeing that, so let's erase that mess here. So from negative 3 to 1, and then starting from 5 to infinity. Where is f prime increasing? Okay, so that's the part where the picture is increasing. That happens here. So f prime is increasing from negative 1 to 3. And where is it decreasing? That would be from negative infinity to negative 1, union, and then, is it 3? 3 to infinity. So this part here where the f prime is decreasing, not f, but f prime is decreasing. All right, so let's look. So then where is it concave? Where is f concave up? So that's where the second derivative of f is concave. The second derivative is, positive. So the second derivative is positive wherever the first derivative is increasing. So this here and this here will almost be identical. The only difference is concavity is never inclusive. So it's going to go from negative 1 to 3. And the reason why is that's where the first derivative is increasing by definition of concavity of f of x is that's going to be where the function is concave up, is where its derivative is increasing. And then for concave down, it will be the same thing, but for decreasing. But its concavity is a comparison of 3 points, so that's never inclusive. Okay. And where does f prime of x have a relative minimum? So what x value does f prime of x have a relative minimum? It's going to have one here. So that's going to be at negative 1. It's going to have one right here, a relative maximum. That's going to be at x is 3. And where does it have, f of x have points of inflection? Well, in this case where there's relative maxes and mins of the derivative, as long as it's differentiable there, it's going to have points of inflection. So it's going to have a point of inflection at both negative 1 and negative 3 because it is f of x is concave down and then concave up at negative 1. So there's a change in concavity from positive to negative, and there's also a change in concavity of f of x at 3 because it goes from concave up to concave down at 3. Now, where's the relative? So now if I'm looking at these two questions over here on the left, f of x has a relative minimum at x is equal to. Now, that's where the derivative is equal to 0 because I'm asking for f of x now over here. So that will happen here, here, and here. I just have to determine if it's a relative max or a min. But if f prime is positive, that means the function is f of x is increasing and then decreasing. So right here, that would have to be a maximum relative max of f of x on f of x. And right here would be a relative min of f of x. And at this value here, again, is going to be a relative max of f of x because f of x on here is increasing and then it starts decreasing. So if a function increases and starts decreasing, there must have been a relative maximum there. So there is a minimum at x is equal to 1 and the maximum at negative 3, 5. Those are the two possibilities for that. All right. I'm just going to give you the answer to check yourself. You're supposed to do that on your own. So if you need to check your answers, you can always come here and have a look. or screenshot it or whatever you need to do.